All right, lesson 116 is on probability. And we began by looking at a set of letters. If we have 3 letters, A, B, C, and we ask the question, how many different ways can those letters be arranged? Well, first we could go, A could go first, B, then C, or A could go and then C, B, right? Or we could say B goes, then A, C, and then B with C, A. Then we could start with C, and it could go A, B, or C, B, A. So really, if I don't reuse the letters, if once I've used A, then I only have a choice of B or C to use, right? That's without reusing the letters. Each one of these arrangements is what defines a permutation. Okay, so each individual arrangement that is available with that set of letters is called a permutation. All right. Now, when we look at the probability, or how many permutations there can be, well, when I'm looking at the first letter, right, and then the second letter, and then the third letter, right, because we have 3 letters, and we want to arrange them in sets of 3. And if I, without reusing the letters, I look at my permutations like this. Well, when I choose the first letter, I have 3 letters to choose from, right? Now, one of the letters is already chosen. So the second choice of letters that I make, I only have 2 letters to choose from, right? And when I pick my third letter, I'm only left with 1 choice. So without reusing them, the number of permutations or arrangements of letters that I would have is 3 times 2 times 1, which is 6, which I have shown at this point. Now, sometimes we look at permutations where we can reuse, where repetition of the letters, is allowed. All right? And we will come up with a much larger number of permutations because the first time I have, of course, 3 letters, A, B, or C. I can use any 3 of them. Now, if I can use repetition, then the one that I used first, I can use again, so I still have 3 to choose from, right? And again, the third time. And 3 times 3 times 3 is 27 permutations. All right? Let's look at problem 116.1. And this is all permutations, which is very closely related to probability. All right? 116.1 says, how many different ways can the numbers 3, 5, 7, and 8 be arranged in order if there's no repetition permitted? So I cannot repeat the numbers. So in my first number, second number, third number, fourth number. My first number, I have 4 numbers to choose from. The second time, I can't repeat, so I only have 3 to choose from, then 2, then 1. Actually, you can do this on your calculator. Let's say I had 50 numbers. In your calculator, it's 4 asterisk, which means 4 factorial, all right? And factorial is on your calculator, and it's shift x to the -1. So let's go ahead and multiply 4 times 3 times 2 times 1. 4 times 3 times 2 times 1 equals 24. Now, if I did 4 factorial, and it has to go from the highest number down, 4 factorial equals 4 times 3 times 2 times 1, okay? If I did 4, shift X1, you'll see the asterisk show up, and it equals the same number, 24, all right? That is not in your book, all right? Now, let's look at 116.2. 116.2 says how many 4-letter signs? So I'm going to have 4 letters. Here's my first, here's my second, third, fourth. How many 4-letter signs can be made from the words equal if repetition is permitted? So I can repeat the use of the letters, and I have 5 letters available. So, and they're 5 different unique letters, which matters, all right? The first choice, I have 5 to choose from. The second, I have 5 to choose from. Then I have 5 again and 5 again. That I can multiply 5 times 5 times 5 times 5, or I could say what? 5 to the 4th power, can't I? All right? So 5 to the 4th power is 625. And that's my number of permutations. All right? Let's look at 116.3. 116.3 says, a multiple choice quiz has 8 questions. And there are 4 possible answers to each question. So we have 8. 1, 2, 3, 4, 5, 6, 7, 8 questions, right? And for each question, there are 4 answers. So for this question, there's 4. This question, there's 4. This question, there's 4. 4, 4, 4, 4, 4. How many permutations? It would be 4 to the 8th power, right? 4 to the 8th power, which equals 65,536. All right, let's look at 116.4. Practice problem 116.4. All right, it says, how many 3-letter signs can be made? So we're going to have 3 letters. First letter, second letter, third letter. How many 3-letter signs can be made from the letters numeral N-U-M-E-R-A-L if no repetition is allowed? All right. So for the first letter, I have 1, 2, 3, 4, 5, 6, 7 choices, right? I've used 1. Now I have 6 letters to choose from, then 5. So it'll be 7 times 6 times 5, which equals 210. And the last one for permutations, let's look at 116.5. Then we will move on to probability. All right. Jamie had 5 places to put items in her display. 5 places. 1, 2, 3, 4, 5 places to put them. All right. She has 38 items. 38 items. How many arrangements are possible? Well, with her first choice, she has a pool of 38 items to choose from. Then after she's placed one, she now has 37, then 36, then 35, then 34. And that is a very big number, okay? Now, let's look at the second part of this lesson. Probability. Very closely related to permutations, all right? So probability is really chance. It's the chance that something will happen, okay? So, if I have a dice has a 1 on it, a die, actually, singular, right? It has 3 on it. It has 4. Of course, they're not numbers, they're dots, right? 5 and a 6. And I ask you, what is the chance that I roll this dice and I come up with the number 2? Okay? how many 2s are there on the dice? 1, that's what goes in the numerator. What are the total number of choices that can be rolled on the dice? And there are 6, right? So the chance of me rolling a 2 would be 1/6. Now what if I ask you, what is the chance of me rolling a number greater than 3? Well, how many numbers are greater than 3 goes in your numerator? That's 3. So, and how many total we have is 6, or it's 1/2. We can ask, what is the probability if we have 2 dice of rolling a sum of 7? And you'd have to figure out how many dice, what would be the combinations in the dice that you would roll that would get 7. So with probability, a lot of times it's, we use dice and we use coins, all right? So if I had a coin, a penny, we know one side is heads, one side is tails, right? If I flip the coin, what is the probability that I would get heads? Well, I'd ask myself, in the numerator, it's how many of those outcomes could I have? And there's only one head, right, on a penny. And how many, what are my choices? Heads and tails, there are 2 choices, okay? All right, so let's look at 116.6. In 116.6, we do have 2 dice, all right? And it asks on page 472, what is the probability of A getting a sum of 7? So we want the sum to be 7. So I ask myself, what could I roll on the dice such that the sum would be 7? Well, I could do 1 and 6, right? I could do 2 and 5. I could do 3 and 4. If I rolled 4 on this dice, I could get 3 on this one. If I rolled 5 on this dice, I could get 2 on that one. If I rolled 6 here, I could get 1. So our permutations, here are our individual arrangements, right? 1, 2, 3, 4, 5, 6 out of. And now, what would my denominator be? My denominator would be 6 out of, what are my total possibilities? It's 6 times 6, or 36, because there's 6 on each dice. And that equals, we simplify it, 1/6. Okay? B says, what is the probability of getting a sum greater than 8? So the sum has to be greater than 8. Can I roll 1 and anything to get greater than 8? No. 2? No, because the highest other dice would be a 6, and that equals 8. That's not greater than 8. 3. Not, okay, let's start with 6 and go down. 3 and 6 would definitely be greater than 8. 3 and 5 equals 8, so there's no more with 3. See, I'm just moving up on my dice. Does that make sense? So 4 plus 3, no. 4, no. 4 plus 5 is 9, yes. And 4 and 6 is 10, okay? Now what if I go to 5? 5 and 3 is 8, so I can roll 5 and 4, I can roll 5 and 5, I can roll 5 and 6. Now we go to the 6. 6 I can roll, not 2 because that's 8, 3, I can do 6 with 4, 6 with 5, and 6 with 6. So how many permutations do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 out of 36, which can be simplified, correct? Both of them are divisible by 2, so that would be 5 and 1/18. So 5/18 would be the probability that I get a sum greater than 8. And then let's look at 116.7. The last